Assalamu alaikum wa rahmatullahi wa barakatuh. So here we go again with the rest of the exam, SAAT, تحصيلي exam, right? So let's go through the rest of the questions. Bismillah ar-Rahman ar-Rahim. The electric energy used in operating a 60-watt light bulb for 2 minutes would be, right? Okay. Recalling the energy power formula, right? Now, power is defined as the amount of energy change in a given time, right? So in this case, simply rearranging the formula will give us that the energy is equal to power times time, right? So that would be 60 watts times 2, right? But again, we are dealing with SI units, and the standard international unit for time should be seconds, right? So you have to convert the 2 minutes into seconds, right? So that would be 2 times 60. Okay, so the answer is going to be 7,200 joules, right? So as you can see now, the joule itself only, like 7,200 is not here. We have an alternative unit, which is, or prefix, that is in kilojoules, right? So the answer here is 7.2 kilojoules. Now, the unit for measuring magnetic field strength is, okay? Magnetic field strength is how strong a magnet or a charged particle can affect with a magnetic force on the surroundings, right? So the standard international unit for magnetic field strength is Tesla, right? However, there are other alternative units, like for example, if we recall the force applied over a current carrying wire that falls into a magnetic field, it's equal to BIL, where B is the magnetic field strength, right? In Tesla, I stands for the current intensity, L is the length, right? This is in meters. I'm sorry, this is in ampere, sorry. And this is in meters. And this is the magnetic field strength. We can fix it now to make things clear, right? This is the magnetic field strength, and it's measured in Tesla. Rearranging this formula, it gives us that B is equal to F over I L, which is Newton over ampere meter, right? So both A and B are correct answers, right? So this tells you not to rush things while choosing your answer. So you have to choose your answer carefully. So the answer here is D, both A and B. Question 19, induced EMF can be found using the formula, right? This is an easy question. When a voltage is induced as a result of a wire rotating inside a magnetic field, right? This can be found using the formula BLV sine theta, right? BLV sine theta, where B is the magnetic field strength, L is the length of the wire, and V is the speed of rotation, okay? So the answer here is A. The measuring unit for relative electric isolation constant is, right? This one, actually, it has no unit. One of the few physical quantities that have no unit, right? A quick review also for them, right? This includes refractive index, right? It has no unit. Also, coefficient of friction, it has no unit. And this one, the relative electric isolation constant, right? It also has no unit, right? So the answer is D. Next question. A 5.17 electron volt ray falls on a photocell. While the work function of the photocell material is 2.31 electron volt, what is the energy of the released electron, right? A quick review here. If a photon falls on a metal, right? So this is a metallic plate and there is a photon falling on it. In order for the photoelectric effect to happen, the energy of the photon must be more than the work function of the metal, right? So in this case, the energy of the electron that would come out would be equal to the energy of the photon minus the work function, which has this symbol, right? So here, the energy of the photon is 5.17 minus the energy of, or the work function is 2.31. So when you subtract them, the final answer would be 2.86 electron volt, right? The shift in scattered photons energy is called, right? This is called Compton shift. Let me quickly recall this part, right? So assuming that I have a photon going and it's going to collide with an electron. This is an electron and this is a photon, right? Now, after the collision, let's say, for example, that the electron is going to move in this way and the photon will move in that way, right? That's the photon. Now, we know that part of the energy, again, part of the energy of the photon, some of it was given to the electron, right? Some of it. So in this case, the energy of the photon, I can say that the energy of the photon has decreases or decreased, right? The energy of the photon decreases, and accordingly, the frequency of the photon also decreases. And since that the frequency decreases and the frequency and wavelength are inversely proportional, so the frequency decreases, the wavelength of the photon increases, and this is what is called Compton effect or Compton shift sometimes, right? It's the change in the wavelength of an incoming photon when it collides with an electron, okay? So here, the answer is B, Compton effect. Next question. Emission spectrum of hydrogen atom has, right? The emission spectrum is when we apply voltage on hydrogen gas, which is found inside the tube, right? The hydrogen is going to produce specifically 4 distinct lines with very, very specific wavelengths, right? Which look like this here. This is the emission spectrum of hydrogen specifically, right? How does it look like? 4 lines, as you can see here. Next, the unknown isotope in the following reaction would be, right? Now, in this reaction, there is a very, very famous rule that you have to follow when you go through nuclear reaction, which is the total sum of the atomic number at the bottom on the right side should be equal to the total sum on the left side, and the total sum of the mass number on the right should be same as on the left, right? So going through these parts, we will say that, we can say that here, the total sum of the mass number is 15, right? And for the atomic number, the total sum is 7, right? Accordingly, if this is 6, the atomic number here should be 1, and if this is 14, the mass number here should be 1, such that the total sum on the right side should be the same as the total sum on the left side, right? So this leaves us with hydrogen 1, 1, right? So the answer here is C, hydrogen 1, 1. Last question. When an electron and a positron collide with one another, they annihilate each other. Annihilate each other means they destroy each other, releasing gamma rays. What is the least energy for gamma rays, knowing that the energy of an electron is 0.51 million electron volts, right? A quick review about the positron, right? That beta particles are made into two types, two main types. We have positive beta particles, which is E plus 1, 0, which is called a positron. And we have E minus 1, 0, which is an electron. Okay, what is the difference between them? Actually, the only difference between them is the charge, right? A positron is a particle that has exactly the same mass of an electron, but it is positively charged, right? So if both of them collided with each other, right, and each one of them is carrying energy of 0.51 million electron volts, so in this case, the gamma rays coming out from both of them is the sum of both of them together, which gives us 1.02 million electron volts, right? So here, the answer is B. Okay, now I hope that you have enjoyed this session and you got the most benefit of it. Don't forget to subscribe in the channel and see you inshallah in the next videos. Thank you very much. Assalamu alaikum.